Okay, you note on first given data. You note on first given data. Okay, so Z1 equal to how much? 24. Okay, so N1 equal to 1500 RPM and N2 equal to 500 RPM. Phase width. Okay, so module AM is given 5 mm here, and module A, okay, is 5 mm, and phase width is 36 mm here. Okay, so B equal to 36 mm. Okay, and tooth profile, so alpha is given 14.5 degree. Okay, now you need to find out what is the power transmitted by this pair of spur gears. Okay, so one thing is that you need to find out the weaker member here. Okay, now they have given material here. They have given a material. Okay, so high grade one is what a cast steel pinion is there. Okay, so let us go for solution. So what you can say the static stress for pinion and gear. Okay, so now to get the static stress for pinion and gear, so let us refer a design data handbook here. Okay, so go for table number. Okay, so now table number 12.7, table number 12.7. Okay, so first what it is, it's a cast steel pinion. Okay, so now this is what a sigma d1. Okay, so now down cast steel pinion, let us consider it as a 0.2 percentage carbon heat treated. Okay, so assuming heat treated. Okay, so now heat treated, it is 193.2 Newton per mm square. Okay, next high grade cast iron, high grade cast iron gear is equal to what? Sigma d2. Now high grade cast iron, okay, so now you just refer cast iron grade 35 heat treated. Okay, so 78.5. Right, Amo,
Yes, sir.
whether your division students are going for labs, ಇವಾಗೇನಾರ ಲ್ಯಾಬ್ ನಡೆದವ ನಿಮ್ಮ
Yes,
ಡಿವಿಷನ್?
sir.
ಹೌದಾ?
Morning ಇಲ್ಲ sir, afternoon ಅದ sir labs.
ಆಫ್ಟರ್ನೂನ್ ಅದಲ್ಲ? ಓಕೆ,
ಹಾ sir.
ರೈಟ್. So now let us go for finding out the weaker member. Hmm? Let us go for finding out the weaker member. First is what? Identify weaker member. Okay? Identify weaker member. To identify weaker member, what you need? You need a form factor. You need form factor. Okay. So to get the form factor, you need a value of Z1 and Z2. Okay? You need value of Z1 and Z2. Now Z1 is given. So now Z2 equal to what? So Z2 equal to Z1 into so N1 by N2. Okay. So what Z1 is 24, 1500 divided by 500. I think you are going to get 72 teeth here. Okay. Z equal to 72 teeth. Now form factor for pinion, this is equal to y1. Okay. Now it is a 14.5 degree profile is there. 14.5 degree profile is there. Let us go for equation. 14.5 degree. 14.5 degree here. So now 0.124 minus 0.618 divided by Z1. Now how much you got here? Okay. Similarly for gear here, for gear, okay. Similarly for gear. Now someone calculate. How much you got a Y1? So how much you got a Y1?
0.098, sir.
0.098. One more digit.
2 pi.
Now for gear,
0.1154.
0.1154. Okay. So now let us calculate here. So sigma D1 is 193.2 into 0.09825. This is 78.5 into 0.1154. Now sigma D1 into Y1 is how much? Yes, per throw 193.2 into 0.09825.
Sir, 18.9819.
18 point.
9819.
Okay. So for gear, how much you are going to get?
9.0589.
0.0589. Okay. So now which is the weaker member here? So now weaker member is gear. Okay. Weaker member is gear. So now you need to find out the power based on the gear parameter. Okay. So now right here. So weaker member is gear, hence power to be calculated based on gear parameter. Okay, gear parameter. Okay. Now you know the tangential tooth load based on Levy's equation. Based on Levy's equation. So Ft equal to sigma d Cv y by b into m. Right? This is what equation. So you can refer design data handbook. Notify equation number 12 point. Let us notify here. 12.5a. Okay. 12.5a. Now in this you can just talk about sigma d is now you need to find out the value of Cv here. Y is already noted, pi is noted, pi is okay, b is given, m is given. Unknown parameter here is a Cv. Okay, unknown parameter is a Cv. Okay, let us find out velocity factor here. Okay, so now to find out the velocity factor, you need velocity. Okay, so now you need to find out the d2 here. Okay, so now d2 equal to what? It is a pitch circle diameter of a gear. Okay, so now d2 equal to z2 into m. Z2 is 72, M is 5 here. Now how much you are going to get? 360 mm. So now you find out V here. V equal to pi 360. Okay. N2 is how much? 500 divided by 60 into 1000. Now you find out what is the velocity here.
9.42, sir.
5.42 meter per second. Okay.
9.42, sir.
9.42. Sorry. Okay. Now, so for 9.42 meter per second, so what is the compatible equation to get the value of Cv here? Okay. So now you can refer equation number 12.6b to find out the value of Cv here. Okay. So now referring equation number 12.6b. Okay. So now velocity factor. Okay. So referring design data handbook equation number 12.6b. Okay. So Cv equal to 4.58 divided by 4.58 plus b. Now this is what 4.58 divided by 4.58 plus 9.42. Okay, now we calculate value of Cv.
Point 3270.
0.3270. Okay, now let us substitute all these parameters in tangential tooth load equation. Okay, now Ft equal to pi sigma d is 75.2. 75.2 is there? Sorry, 78.5. 78.5. Okay, Cv you got 0.327. Okay, y2 you got how much you got y2? So 0.1154. Y2 is there. Sigma d is over, Cv is over, y2 is over, pi is over, b is given 36, m is given 5m. Now you find out ft.
1675.
1675.1187
.1187, sir.
Newton. Okay. Now, so you know that tangential tooth load based on power transmission. tangential tooth load based on power transmission. Okay, so Ft equal to 9.55 into 10 to the power of 6 into P into Cs divided by N2 R2 here. Okay, N2 R2. So N2 is speed of gear, R2 is the circle radius of the gear. Okay. Now assuming service factor CS equal to 1.25. Okay, 1.25. So R2 equal to how much you are going to get R2 here? 180. 180 mm. Okay. So N2 equal to 500 RPM. Okay. Now, so power P in kilowatt you are going to get in terms of kilowatt here. Okay. So Ft into N2 into R2 divided by 9.55 into 10 to the power of 6 into CS here. Let us substitute. Let us substitute. Ft is 1675.187. Okay. N2 is 500. Okay. R2 is 180 divided by 9.55 into 10 to the power of 6. Okay. Into 1.25.
12.6291 kilowatts, sir.
12.6291.
91.
Okay, let us go for 12.63 kilowatt. Okay, so you write a comment here. The maximum power that can be transmitted by this pair of spur gear is 12.63 kilowatt. Okay, 12.63 kilowatt, right? So now you can get some other type of problems where you need to go for little trial and error method. Okay? You need to go for trial and error method to get the value of parameters what they are required. Okay? Next, suppose if they given based on the endurance surface. Okay, I think we have not done endurance based surface mainly. Okay, just note on one more problem, last problem. Okay, note down. So the following data are the following data are the details of a spur gear. So pair of spur gear, gears. Okay. Now I'll write here details. So first is speed. Okay. Second one is level bending stress. It's what sigma d. Next third one is the surface hardness BHN. Next modulus of elasticity here. Okay. Modulus of elasticity. Tooth profile. So next is face width. Now first is pinion here, second one is gear. Okay. So this is 1440, sigma d is 200, bhn is 250, modulus of velocity is 200 gigapascal. So tooth profile is 20-degree, full depth invalid. Okay. Face width is 32 mm. Okay. So for gear it is 720 rpm. Allowable bending stress is 180. Harness is 200. Again it's 200 GPa. This is 20-degree full depth and this was 32 mm. Okay. So 32. Next you note down. The central distance is, if you have any work, the central distance is 132 mm. The pinion has 22 teeth. Determine the power determine the power that can be transmitted that can be transmitted now based on, you just look out here, based on, okay, first criteria, bending strength, bending strength, ಯಾರೋದು second criteria, surface endurance strength, surface endurance strength. Okay, next note down. Now they have given sorry, wait a minute. Now they have given here everything also. Okay, you note down. The gears are manufactured the gears are manufactured okay, to have an error in action less than 0.02 mm. Okay, what should be the what should be the endurance strength of the weaker member to have endurance strength of 1.25 times the dynamic load. The dynamic load. Okay. You need to find out, first thing is, what is the power based on bending strength, okay, and what is the power based on endurance strength. So next you need to find out what is the endurance strength of a weaker member. So if the dynamic load is of 1.25 times, okay, if the dynamic load is of 1.25 times, okay. So now let us note down all given data, okay, find out what is the weaker, which one is the weaker member, okay, which one is the weaker member. Okay. Next, okay, so now note down given data, okay, note down given data properly. Let us note down. Okay. So N1 is 1440, N2 is 720. So speed ratio is 2 here, sigma D1, sigma D2, BHN1, BHN2. Okay. So 200, 180, 250, 200. Okay. You write a units here. Okay. Next, E is given. Okay. So E1 equal to E2 equal to 200 gigapascal. Alpha is 20 degree full depth. Okay, 20 degree full depth. And phase width B is, it is 32 mm. Okay, 32 mm. Okay. So first you need to find out which one is a weaker member. Okay. Now first thing is what? Let us go for solution. So identify weaker member. Okay. So to identify weaker member, now Z1 is given here. Z1 is 22 teeth. Okay. Center distance is given. Center distance is 132 mm. Okay. Center distance is 132 mm. Right. Now to identify weaker member, so you need Z1 and Z2. Okay. Now Z1 and Z2 are given here. Z1 and Z2 are given. Okay. So now Z1 equal to how much here? It is 22. Now Z2 equal to 2 into 22. It is a 44. Now material property also is given. Sigma D1 is given. Sigma D2 is given. Right. So first you find out which one is a weaker member. Okay. So now let us go for form factor for opinion. This is what y1. Okay. Now it is for 20 degree full depth. Okay. So note on equation. From data handbook you note on equation. So we have a next class 0.179 minus x175 of 175 not a 9 minus 0.915 divided by z1. It's 95 not 9 and 95. Now you calculate, someone calculate y1 equal to 0.175 minus 0.95 divided by 22. Okay. Now for gear, this is 0.175 minus 0.95 divided by 44. I think this is to be 0.915. You check out in any other handbook books whether it is a 9.5 or 9 point. Now they have gone for 20 degree full depth invalid, not a stub. Okay, it is a invalid full depth invalid. You go for 12.5b equation. Okay? Sorry, 12.5d equation. So this is full depth invalid. Okay, FDI. Okay. Now we go for equation. So refer design data handbook. Notify equation number 12.5d. So y1 equal to 0.154 minus 0.912 divided by z1. Now this is equal to 0.154 minus 0.912 divided by 22. Find out. And similarly y2 here, similarly y2. So y2 equal to 0.154 minus 0.912, that is what, 44. Strength of member. So much value of y1?
0.1125, sir.
0.1125. So y2?
0.1332.
0.1.
332.
Okay, so now find out strength of members. Now sigma d1 into y1 here. Sigma d1 is 200. This is 0.1125. So first it is of pinion. Okay. Next we'll go for gear. Sigma d2 into y2. How much you got? ಎಷ್ಟು ಬರ್ತಾರೆ ಎರಡು?
Sir, 22.5 for pinion. And this is 23.976.
Okay, so now in this case weaker member is pinion. Okay. Weaker member is pinion. Okay. Now as you need the value of m here. Okay. As you need value of m. Okay. Let us go for solution. Okay. Let's go for solution. Now I will go for next bit. Okay. That is what? Tangential tooth load based on Levy's equation. Okay. So notify design data handbook. So equation number 12.5a. So now this is what? Tangential tooth load Ft equal to pi d1 cv b, sorry, y into m. Okay. Now in this case, if you look out, cv is unknown, m is unknown, b is given, y1 you have calculated, right? Y1 you have calculated. Now we need to find out velocity factor cv and modulo m. Modulo m. Okay. Now as the central distance is given here, okay, so let us go for calculation of pitch circle diameter of pinion and gear. Okay. Now central distance A is given. This is equal to what? D1 plus D2 divided by 2. Okay. D1 plus D2 divided by 2. Now you just look out here. So now this distance is given here. This is equal to what? A. Okay. Now you have a pinion here. Okay. You have a gear here. Right. So now this is what? Pitch circle diameter of pinion. This is pitch circle diameter of gear. Now how are we going to get distance here? This is what? R1. This is what? R2. So that can be written as D1 plus D2 divided by 2. Okay. Now let us look out the parameters here. So D1 and D2. Okay. Now as you know the speed ratio here, as you know the speed ratio, so now D1 D2 equal to 2 times of D1. D2 equal to 2 times of D1. So now if you go for the relation here, pi D1 N1 equal to pi D2 N2. Okay. So what we are going to get here, d1 by d2 equal to n2 by n1 or vice versa. Okay, right? And we can just look out this velocity ratio factor. I am just directly writing this equation d2 equal to 2 times of d1. Okay, now center distance is 132 mm. Okay, now this is equal to what? d1 plus 2d1 divided by 2. Okay, now this pitch circle diameter d1 can be replaced in terms of z1 yam. In terms of z1 yam. Okay, z1 is how much? 22. Okay, z1 is 22. Now we substitute here d1 equal to 22 times of yam. Now let us substitute back in this equation. So 132, okay, equal to 22 yam plus 2 into 22 yam divided by 2. You find out value of yam here. You find out value of yam. How much you will get? This is 132
4
into divided by 66. It is 4 mm. 4 mm, right? So m equal to what? 4 mm, right? Now you can calculate velocity factor here. You can calculate velocity factor. Okay. So to get the value of CV, you need V. V equal to what? Pi d1 n1 divided by 60 into 1000 here. Okay, 60 into 1000. Now you find out V. So pi 4 into 22. Okay, speed is how much? 1440 divided by 60 into 1000 here. Now find out how much velocity we are going to get. So now referring design data and book. Okay, for velocity so much. So refer equation number 12 point something is there. Now you find out how much velocity you are going to get here. ಎಷ್ಟು ಬಂತು velocity?
6.635 meter per second.
6.635 meter per second. Okay, now you can go for equation number 12.6a. Okay, 12.6a. Now cv equal to 3.05 divided by 3.05 plus v. Okay,
CV equal to 0.4083, sir.
0.4083. Okay, I think now you got all parameters to find out the value of ft here. Okay, to find out the value of ft. Okay, now you substitute ft equal to pi D. Okay, CV is 0.083. Okay, now this is what pi sigma D CV. B is 32 mm is here. Y, you note down how much you got for gear. For pinion it is Y 0.1125, 1125. Okay, and M is 4 here. Now you find out FT. Now you find out FT. Then you find out power based on beam strength. Okay, based on beam strength. Use this equation. What is the value you are going to get FT here? Use this one to calculate the power. Now what is the power you are going to obtain by this equation is based on the strength. Okay. So tomorrow we'll discuss about how to calculate the power based on the endurance strength when they have given condition that so the endurance strength should be 1.25 times of the dynamic tooth load. Okay. Now in this case you need to find out what is the endurance strength you are going to get. Then you need to equate it for dynamic strength. In dynamic strength you are going to get the value of 50 there. Use that FT value to find out the power. Okay. So we'll continue tomorrow. I'll just wind up here. Wait for 2 seconds. I'll take an attendance.